All right, this is pre-algebra lesson 8.1, relations and functions. Okay, like I was just telling you, there's not a lot of arithmetic in this. It's simply, you have to be able to wrap your brain around this. This is the first day in starting, oh man, like this really is the first day of you doing something that will end, I don't know, your sophomore year of college, for real, you understanding functions, relations, the coordinate plane. I mean, just, this is the beginning. I know you guys did a little bit of this last year, but you're now going to actually start it with the right terms and the right concepts. So here's the deal, a function, okay, let's read together top of page 400. I want us all on the top of page 400. We're going to read together so you can see those highlighted words. You really need to pay attention to them. Okay, are we all with me? The table shows the results of a canned food drive. That means people that collect cans. We do a canned food drive when we give it to the Bay Area Rescue Mission, right? You can write the data in the table as a relation, which is a set of ordered pairs. The first coordinate of each ordered pair is the number of students in a homeroom. The second coordinate is the number of cans the students in that homeroom collected. So let's look at the table, right? Homeroom number 101, they have 25 students, and the number of cans they have is 133. Homeroom 102 has 22 students, and they brought in 216. Do you see what I'm talking about here? Do you see the table? You all see the table? Okay. You can write down each one as an ordered pair. The ordered pair as in, like, okay, what would go here? What's the x coordinate? What's the first coordinate?
0.
No, what's the first coordinate? What did they say? What did they say? The first coordinate in any of these would be the
Students.
the number of students. The first coordinate in each ordered pair is the number of students in the homeroom, right? So this would be the number of students. So for the first one, we would put 25. And then the second coordinate is the number of cans the students in that homeroom collected, so it would be 25, 133. Does that make sense? And we could graph this way. That could go on the graph. The next homeroom 102 could be 22, 216. It could be 24, 148. Do you see what I'm saying? We could graph that. All right. The relation is the set of coordinates. Okay, once you do write down all those coordinates, the 25, 133, 22, 216, the 24, and 148, all of these things, these all form what's called a relation. Okay, they form what's called a relation. Now, the next line here says, here's the relation represented by the table. They've written down all the things I was about to, right? The braces indicate that these are all ordered pairs in the relation. So if I was, once you've written them all out like that, once you've written them down, you put them in the brackets, the little braces like thing, and that shows you these are all part of one relation. Okay, we're talking about one coordinate plane, one relation. The first coordinates are the domain of the relation, and the second coordinates are the range. I'm going to explain all this in a second. The first one, the 25, 22, 24, those are the domain. And the 133, 216, 148, those are the range. Okay? Some relations are functions. In a function, each member of the domain is paired with exactly one member of the range. Okay. Now I will explain. Okay? You ready for me to explain? Here's the deal. Whenever you have a function means this. Truly, pay attention. You're up here. A function. Imagine that there is a machine, okay? There's a machine. And you can put something into the machine, right? And something comes out of the machine, okay? Something goes in, something comes out. What makes it a function is when something gets done to whatever you put in here, and it spits out something every time, okay? Here's the deal. Here's how a function works. Let me give you a basic function, x plus 2, okay? If I shove in something, okay, when I shove in something, what you shove in is called the x. That's the input. X You might want to write this stuff down. X equals input. I would write down everything. X equals input, Y equals output. What you put inside the function is the X. What comes out is the Y. I'll just trust me. Write down exactly what I have here. Everybody drawn the chart here and written down. X is the input, Y is the output. You should have exactly what I have down here on your paper. In a function, okay, when you put one number in, only one number can come out. Okay? When it's a function, you put one number in, only one number comes out. That's the important thing about a function. Okay? For this function, if when I put in a number, choose a number, give me a number, put in 25. If you put the number 25, a big old fat 25 coin into this machine, what does the machine do to the 25? It adds 2 to it, right? And listen, what I put in is the X, right? What I put in is the X. So when I shove in a 25, right? I shove in 25, that's the X. What does the machine do to the 25? Well, it adds 2 to it. So then what comes out? 25 goes in, 27 comes out. Does that make sense? If I shoved in a 25 into here 100 times, what's going to come out? Is it possible that every time, well, hold on. Is it possible that when I put the 25 into this machine that a 50 is going to come out? No. What's going to happen to the 25 every time?
It's going to be added 27.
2 is going to get added to it every time. So when I put a 25 in, a 27 comes out. That's all there is to it. Does that make sense? If this machine adds 2 to it, when I put a 25 in, a 27 comes out every time. Does that make sense? If I put in a -6, if I put in a -6, what comes out?
-4. Oh, wait.
-4 comes out, right? If I put in a -6, if I have, what is -6 plus 2? -4. A -4 comes out. No matter how many times I put -6 in, what comes out? A -4, right? This is a function here because whatever I put in, one thing comes out. Does that make sense? So I'm going to show you now, a situation. Let's take our data here. Okay, let's take our data that they had, that we were talking about, and let's see what happens. We're going to see if this is a function or not. Okay, we're going to see if it's a function. Remember, each one of those coordinates, you have 25 and 133. There's 1, which means that, listen, what is this one? That's the X, which is called the
Domain.
it's the input, right? The X is the input. This is what you put in, right? If I put in 25 students, right? How many cans did that class bring in? 133. Does that make sense? So you put in 25 students, 133 came out. Okay. When I put in 22 students, 216 came out. Do you see what I'm saying? I'm going down the list here. I'm going down the coordinates. Do you see what I'm talking about? I'm looking at the coordinates. 22, 116. When I put in 22, 216 came out. It's still possible that this is a function because when I put in 25, 133 came out. When I put in 22, 216 came out. Let's look at the next one. The next one is 24, 148. So far, so good. When I put in 24, 148 came out. So far, we're looking okay. Let's look at the next one. Ooh, the next class also has 22 students. This time, 195 came out. Wait a second. Look here. In this whole thing, remember when they had the little squiggly lines? This whole thing is relation. When I put in 25, what came out? 133. When I put in 22, what came out? Okay. When I put in 24, what came out? 148. Right. When I put in 22, what came out? Oh, wait a second. 195 came out this time. So that means that in this situation, when I put in 22, what came out? 216 one time and 195 another time. Does that make sense? Then guess what? Then this is not a function. This is not a function. No. It's not a function because when I put in 22 two different things came out. What's the rule to be a function? One thing in,
One thing out.
one thing out. That's the whole deal. One thing in, one thing out. Does that make sense? Okay. Let me show you this. Remember, so we have the x is input, and the y is output. Right? We know this. Another name for these things, you ready for this? Another name for them is the domain and the range. Okay, the domain is also the input. Okay, the x, all the numbers that x can be, that's what the domain is. And all the numbers that y can be, that's the range. Okay, so then, watch this. Let's do those first four again. What you would do is you'd look like this. You'd go 22, and you'd have 216. And then you'd also have 195. I'll get to that in a second. You have 24 and 148, and then you have 25 and 133. Here's what it would look like if you're. This is called a mapping. Okay, what I'm going to do here is to show you what's called a mapping. Here's what it is. You point to where things go. The 22. When I put a 22 in, a 216 and a 195 came out. Are you all up here? Look up here. Look what I'm doing. You need to draw it like this because I'm going to be asking you to make a mapping. 24, 148 came out. 25, 133 came out. You can look at this whole thing, our page here, and know that it's not a function. You can know that it's not a function just by looking at that. How can I know that? Because look at the number 22. This is what goes in. These guys are what goes in. When I plugged in a 22, what came out?
216 and...
Oh, wait, 216 and 195? Not a function. Doesn't work. Now, are we saying that can't have happened? Are we saying that this data is false? Is this data false? No, this is really what happened. All we're saying is that this data is not a function. Okay? That's all we're saying is that it's not a function. Do you all have this written down properly? I'm about to erase it. All right. So here's the deal. Let me give you some coordinates. Okay? The coordinates are 0, 1, 1, 2, 1, 3, and 2, 4. And I want you to tell me whether or not this is a function. So here's what you're going to do. Okay, actually, I'll do this one time for you, then I'm going to give you one to do. If I said, I want you to tell me if this is a function and explain whether or not it is or not, or why it is or why it isn't. What you're going to do is you're going to create a mapping. Okay, it's called a mapping. I don't even think they call it a mapping in 7th grade. Next year, you'll learn that it's called a mapping. You're going to create our list, your domain and range. You're going to go domain and range. Which ones are the domain? The x coordinate, right? The first one, right? And each coordinate, it's the x. So here I'm going to put down a 0, a 1, there already is another 1, and then a 2. Agreed? Because there's a 0, 1, 1, 2. I don't rewrite the 1, right? There's zeros, 1s, and 2s. The only thing we put in the machine here is the zeros, 1s, and 2s. Agreed? Yeah. The range, what comes out? Well, 1 came out. When I put a 0, there was a 1, there was a 2, there was a 3, and a 4. Agreed? Those are the things that came out. Well, when I put in a 0, a 1 came out. When I put in a 1, a 2 came out and a 3 came out. When I put in a 2, a 4 came out. Is this a function? No. Why not?
Because one has two.
Right, 1 had 2 outputs. 1 had 2 different outputs. When I put in a 1, it split up. Nope, not a function. Does that make sense? That is, you have to have that memorized. Now, I'm going to show you something else that's a little bit funky. Ready? Here's some more data. I'm going to do this one for you again. What about this set of data? 0, 1, 1, 2, 2, 2, and 3, 4. Okay, you're watching again. You're just watching. Let's set up our mapping. We have domain, and we have range. Okay, what were all the things that were entered in? What were the numbers that were entered in? 0, 1, 2, and 3. And what are the numbers that came out? 1, 2, and 4. Those are the only numbers that came out. Does that make sense? Yeah. Well, when I put in a 0, what came out? 1. A 1 did. When I put in a 1, what came out?
2.
2. When I put in a 2, what came out? 2. When I put in a 3, what came out? 4. Is this a function?
Yes.
What's the rule about a function?
One out.
1 in, 1 out. When I put in a 0, what came out?
One.
A 1. When I put in a 1, what came out? 2. When I put in a 2, what came out? A 2. So just because they shared the same thing, that's still okay. Does that make sense? This is a function because every one thing I put in there, only one thing came out. Yes, it did double up, but that's okay. That's okay. What you don't want to see is these guys splitting into 2 or splitting into 3. Does that make sense?
Yes.
This is a function. All right, you guys try one. Do these and tell me if it's a function or not, okay? Here we go. -2, 3, 2, 2, and 2, -2. I want you to tell me whether or not it's a function. And I want you to tell it to me. I want you to draw the mapping. Do it right. Is it a function?
No.
No. How come?
Because the positive 2 shares 2 outputs.
Right. So when you do this and you have the domain and the range, you have -2, 2, and 2, and the outputs are 3, 2, and -2. The -2 goes to the 3. The 2 goes to the 2 and the -2. Oh, right. That splits over here, and it goes, oh, no, that's no good. Not a function. Okay? Try one more. Try -5, -4, 0, -4, and 5, -4. Oops, this is supposed to be a -4. Sorry. Function,
Yes.
domain, range. What are the inputs?
Negative 5, 0, and 5.
Okay, and what are how are the outputs? Just -4, right? And they all point to here. And I agree, when you look at this, you go, oh, there's no way that's a function. Because it just looks, oh, wait a second, but each one of these only has one output, right? And so that makes it a function. If I could pound that into your brain, then you're in good shape. Okay, now, there is another way of determining whether or not something's a function. Okay, that's one way. That's a tough way to do it if you have a bunch of data. Okay, if you have a bunch of data, I mean, it's a pain. What if you have a graph, okay, or you have a lot of data and you create a graph? You can figure out if it's a function by just looking at it. And I'll show you what I mean. Here, let's take some more data here. Let's go like this. Here is I'm just going to draw a coordinate plane. Okay, and here will be our data. We have -4, -3. We have 2, 0. We have 2, 3. We have 4, 3. And we have 5, -4. Okay, do you see our data here? Now, could you make a mapping like we just did and figure out if this is a function? Yes. Another way of doing it is if you have a graph. Let's actually graph this. The first one is -4, -3 down here. The next one is a 2, 0, which is right there. The next one is a 2, 3 right here. Then we have a 4, 3 right here. And the 5, -4 is down here. Now, 5, -4. Okay, here's what we're going to do. We are going to do what's called using the vertical line test. First of all, could you look at this data right here and tell me whether it's a function or not?
Yes.
Is it a function?
No.
It is not a function because we know that when you put a 2 in, a 0 came out once, and you put a 2 and a 3 came out. We know it's not a function. So here they are. You agree there's the 2 points that we're talking about? That's 2, 0 and 2, 3. Those are the 2 that we already know makes this not a function. So here's what happens. What you're going to do is you're going to take your pencil or your ruler or your finger, okay, and you're literally going to, here's our pencil, right? And we're literally going to just slide our pencil across this thing, right? We're going to take this thing and we're going to slide our pencil. I'm going to get a ruler if I can find mine. Where is it? Is it right here? No. Okay, I'll use my arm. I'm going to take my ruler or my pencil or whatever, and I'm going to literally start sliding this thing vertically across. At any point, is there 2 points touching my pencil? You know what I'm saying? Like right here, how many points are touching my pencil?
One.
Just one. As I scoot over here, how many points are touching my pencil? 2. Boom. Not a. It does not pass the vertical line test because 2 points are touching my pencil at the same time. As I scoot over, that's okay. Okay. But right here, it's no good. Whenever 2 points are sharing the same vertical line, that makes it not a function. It does not pass the vertical line test. Does that make sense? So we already know. You knew that it was not going to pass because of that. Now you're seeing why it didn't pass, because it does not pass the vertical line test. Does that make sense? When your pencil got to right here, it's touching 2 lines. 2 points, I mean. Does that make sense? Okay, let me give you one, and you tell me whether or not, all I'm going to do right now is just put the graph up here. I'm going to go like this. Well, I'm just going to go like this. Does that pass the vertical line test? Is that a function? You take your pencil, or even in your head, and just kind of slide it across, and is there any place that the line, the lines are touching the pencil in 2 places at the same time?
No.
No, we're good. That makes this a function, right? What about this? What if I have this guy, and I go like this? Is that a function?
No.
No way. As I put my pencil right here, how many times is it touching that thing?
3.
3 times. You know what I'm saying? Like, no way. Anytime, like you have this and you have something like that, not a function. I like to think of it as like a hamburger test. Like if I was to take my deal here, and if I was to go like this, and I took a bun on the top and took a bun on the bottom, and I smashed it all together, does anything fold up on itself?
No.
If I was to smash this down, would anything fold up on itself? No. That means it passes the vertical line test. Does that make sense? And yet, if I go like this, and I smashed it down, does it fold in on top of itself? Would these lines fold on top of themselves? Yes! Therefore, it does not pass the vertical line test. Does that make sense?
Yes.
Make sense? Okay. You guys try one of these. What happens? Here's the deal. Another way of writing this stuff out. So far, we've just given you a list of coordinates, right? You guys try this. I'm going to give you a table. A table will look like this, right? Okay. X's are the first coordinate, right? And the Y's are the second coordinate, right? Or the X is the domain, the Y is the range. Let me give you one. Let's go -6, -5, -3, -2, 0, -2, 1, 0, and 0.43. I want you to graph that for me, please. Do you all know how to graph this? You'd graph it like this, like that's one coordinate, that's one coordinate, that's one coordinate. Does that make sense?
We don't have graph paper. What do we do? We use graph paper.
You need to use graph paper on this, yeah. Anytime we do this, you need to use graph paper. All right, so here we go. When we graph this, it should look like this. Oh, that's a horrible line. Okay. -6, 1, 2, 3, 4, 5, 6, -5. Okay. -3, -2. 0, -2. 0, -2. 1, 0. Oops. And 4, 3. When you do this, yes?
So, when the X is the first number, so like on the far left dot, wouldn't it be one this way?
-6. 1, 2, 3, 4, 5, 6. No, it's right here. That's -6.
Yeah.
Right? And then down 5. -6, -5.
Oh.
Right here's the point. Right? -6, -5. That's -6, -5. When you do this and you draw them, right? When you draw them, does it pass the vertical line test?
Yes, it does.
Is there any place where your pencil would be touching the line twice? No. Do you see that? Did you have that it's a function?
Yes.
Did you write down that it wasn't a function? Why? Look, I really want you to look at this. This is something that is not math, right? I mean, this is just a matter of put your pencil up here and you put it across, and at any point is on my pencil, are there two lines touching my pencil? Ever, right? No, they're not touching, right? I mean, they're separated. Does that make sense? I mean, it's never touching my pencil twice. That makes it a function. Does that make sense? Make sense? Okay. Try another one. Here's our table again. I can give it to you in a table form. I could give it to you in a, whatever. We're going to go negative 1, 3, negative 1, 2, 0, negative 4, and 4, 2. Graph that for me on a coordinate plane and tell me whether or not it's a function. Okay, first of all, if you are not good at graphing, just basics, you have to go home and practice this. You have no chance at being successful in this class if you don't know where 2, 4 is. If you don't know where negative 3, 1 is. You have no chance in this class if you don't know where that is. Do y'all understand what I'm saying? So if you're not good at that, go home onto your computer and practice. There will be all sorts of places, Khan Academy. I mean, you go on there, there's going to be a billion free ways for you to practice this. You have to be good at this. So here is our coordinates. The first one is negative 1, 3, up here. The next one is negative 1, 2. The next one is 0, negative 4. And then the last one is 4, 2. When you draw this, right, and you don't even have to draw the lines. You can just look at this. Does this pass the vertical line test? No. When you're over here and you're going around, oh, boom, right there. They're right on top of each other. They're touching my pencil at the same time. Right here, those two guys are touching my pencil at the same time. Therefore, not a function. Do y'all understand that? Okay. So when they ask you to explain, when you're graphing something and they say, is it a function or not? And they say explain, what would be a reasonable explanation?
The lines do not intersect.
It does not pass the vertical line test. Or it does pass the vertical line test, right? If it's a function, it's because it passed the vertical line test. If it's not a function, it's because it doesn't pass the vertical line test, right? That's the reason why. You can say that in your explanation. Y'all understand?
Yeah.
Okay. Let me give you your homework.
Like,
Huh?
can we like VLT?
Nope.
VLT.
Nope. You can write it out. Page 402, 1 through 22, even. If they tell you to graph something, you graph it. If they tell you to tell me whether it's a function and explain, you can explain. I've already given you the answer for the explanation. You just have to choose which one it is. It either does or it doesn't pass the vertical line test. Okay? There you go.